Today we are going to discuss ray optics. In this, what are the important topics that you have to consider for NEET exam? We are going to have the discussion on it. We are not going to enter into the detailed analysis of the subject in this video because it is not possible within half an hour or 45 minutes. But I will give you what are the important topics and how to prepare for them. Okay. So the ray optics. First of all, the ray optics chapter mainly we can divide into two parts. That is the reflection and refraction part and optical instruments. So two parts. From reflection and refraction, definitely minimum 2 questions will get. Optical instruments, minimum 1 question will get. So overall the ray optics topic you will get minimum at least 3 questions will get, okay, or maximum 4 questions or 5 questions also, sometimes it is possible. So we should not neglect this topic. Some people have that phobia that ray optics is very difficult, but it is not correct actually. It is a very easy topic when you know how to draw the ray diagram correctly and how to use the sign convention properly. Okay, if you are not able to draw the ray diagram and if you have doubts in the sign convention, definitely it will be difficult to you. Okay, so please concentrate on those, the ray diagram rules and also sign convention, right? So let us enter into the topic, that is the ray optics. In this we are having first it is reflection, refraction. Reflection at plane interface or plane mirror and also curved mirror. And similarly refraction through the plane interface and refraction through the curved interface, right? So in each curved cases, like plane means a radius of curvature is infinity, but in each case the curved intercase, curved situation, there will be 2 cases, that is concave mirror. Reflection means definitely it is a mirror. We will discuss in case of ray optics. So there are 2 types of curved mirrors, concave mirror and another is convex mirror. Refraction through the curved interface, there are again 2 cases, concave interface, convex interface. Okay, and in the refraction case, in case of curved interface, there will be one more, that is lens. Okay, so what are the things that we are going to discuss here? Major topics are reflection and refraction. In that, reflection at plane mirror, this is a 10th level topic. You will not find any question in the NEET exam, mostly from the plane mirror case. Okay, and if they are asking, it's very easy level question, it will be okay. And plane mirror reflection is not included in the 12th syllabus. Okay, only reflection at curved mirrors only they have given as a syllabus. Okay, so there are 2 types of curved mirrors. One is concave mirror, another is convex mirror. Concave mirror is this, convex mirror is this, right? So these 2. And next, coming to the refraction through the plane interface. Plane interface means again the radius of curvature of the interface will be infinity. That is what actually plane interface. So this is important, again important topic. And refraction through the curved interface, there will be concave interface and convex interface. And of course the sum of these 2, the applications of these 2 interfaces may be the lens. Okay, and lenses, there are 2 types of lenses. There are 2 types of lenses, convex lenses or convergent lenses. Another one is concave lenses or divergent lenses. Okay, and other than these, there will be dispersion, and after that prism, dispersion through prism, right? Rainbow formation, scattering of light, If it is included in the syllabus, you can read this. Is before you proceed the preparation, just see for this. Okay, scattering of light and rainbow formation is there, of course. That's all. This is about the just ray optics without optical instruments. Okay, so in this actually plane interface, like plane mirror, okay, number of images formed by the plane mirror we'll discuss there. Like two mirrors are inclined at an angle theta, then how to find the number of images there. Okay, that we will discuss. Like mirror formula will be there, that common formula I'll explain that here itself. 1 by v plus 1 by u equals to 1 by f. Okay, this formula is applicable for any mirror, whether concave mirror you are using or convex mirror. This formula is applicable, and also it is applicable for plane mirror, because for plane mirror focal length is infinity. We'll discuss that. Okay, once after the reflection and reflection at plane mirror and curved mirror is completed, we have to enter into the refraction. In refraction there will be refraction through plane interface. In the plane interface refraction there will be 4 cases again, that we will discuss again. Okay, I'll tell you that. And after that, curved interface, refraction through curved interface, as I told you, there will be 2 different cases: convex interface, concave interface, and as a special case, lens will be there. In the lens there will be applications again, applications of this lens. I mean applications in the sense like lens is silver, lens is immersed in a liquid. Okay, lens is cut along the axial line, I mean cut along the axis, cut perpendicular to the axis. Okay, and there will be displacement method to find out the focal length of a convex lens. Okay, so the displacement method also you have to read, right? So I'm going to next page. So first let us see the reflection. I have just given overview of reflection and refraction. Now we are entering into the reflection. What are the topics that we have to concentrate here? Okay, first of all, let me tell you here, for any mirror, 1 by v plus 1 by u is equals to 1 by f is applicable. This is applicable for any mirror, and as a +2 completed student, you already know what is the small u stands for. The small u stands for object distance. Okay, and small v stands for image distance, and f stands for focal length. Okay, and for plane mirror, case 1, if you consider case 1, plane mirror, the focal length of plane surface is infinity. Remember, f is infinity. Then 1 by v plus 1 by u equals to 1 by infinity, which is equals to 0. Something by infinity, you know that is 0. Then we can say v plus u equals to 0, or v equals to minus u. This meaning is very simple. The meaning is very simple here. V is minus u stands for the object distance and image distance both are equal, but in the opposite sides. I mean, if object is in front of the mirror, image will be behind the mirror, like that you can have. Okay, so for example, if you consider this is a plane mirror, this is a plane mirror, and object is placed over here, right? Then this is a real object I can consider. I'll tell you what is real object and what is virtual. Corresponding image will be here. Okay, this is image distance. Say this is virtual image. The distance from plane mirror to the object, this is u, right? And from plane mirror to the image is v. V and u are equal in magnitude. For example, this is 10 centimeter, this is also 10 centimeters, but in the opposite side. Okay, we can say this is called real space, this is called virtual space, right? So according to sign convention, the u is negative. Okay, sorry, v is negative. This is plane mirror, and the mirror formula, how to apply for plane mirror is this case. Next, image formed, the number of images formed due to inclined mirrors. This is also important topic. If there are two mirrors which are inclined at an angle theta, right, this is M1 and M2, then definitely the number of images formed n equals to m minus 1, or otherwise I have to tell you common formula here. Just a minute. N equals to, or first let us define the m equals to 360 by theta. This is m. If this is odd number and even number, there are two possibilities. If it is even number, the number of images will be m minus 1. Odd number, then there are 2 again. If it is odd, then the object is lying on the bisector, okay, then m minus 1. If object is not lying on bisector, then it is equals to m. I hope you got the clarity. There are mainly two cases, even and odd case. If it is even, directly subtract the 1 from the m, that will be the number of images formed. If it is odd, then you should go for the next test, that is, if the object is lying on the bisector, then you should subtract the 1 from m, that is the number of images. If it is not lying on the bisector, then the number of images will be m itself, okay, and this is the case when m is an integer. If m is an like for example m is the fractional number like 2.6 or something like you got, okay, then bracket of that m you have to consider, bracket value of that m you should consider, understand. So my intention is the number of images formed due to the inclined plane mirrors is important topic that you have to concentrate, okay, and this has been explained in the class, okay, and you can see the notes of my class and you can just prepare this. And next coming to this is a like plane mirror case. One more thing we can have, the deviation suffered by light ray in each reflection. Remember, the deviation suffered by light ray in each deflection is the 180 degrees or pi radians minus 2 times angle of incidence, okay. The deviation is 180 minus 2i, where I is angle of incidence, and you know already angle of incidence and angle of reflection are equal, okay. This is laws of reflection, first law of reflection it is. I hope you got the clarity. Angle of incidence and reflection are equal, and delta equals to pi minus 2i. This is also, this formula is also important, and this is about the reflection at plane mirror. And of course next topic will be reflection at the curved mirror that we have to discuss. Reflection at curved mirror. There will be two cases, I told you already, that is concave mirror, which is we call convergent mirror, okay, and case B will be convex mirror, which is divergent mirror, okay. These two are important, and in concave mirror there will be 6 possibilities, 6 cases, okay, case 1, 2, case 2, case 3, case 4 and so on, case 6, okay, and those 6 cases you have to remember, okay. I'll just read the 6 cases here, okay. Case 1, when the object is at infinity, image form will be at the focus, the nature of image will be real, inverted, diminished image. Case 2, if object is beyond the center but not at infinity, then image is in between focus and center, the nature of image is real, inverted, diminished image. Case 3, when the object is at the center, then image also at the center, but the nature of image is real, inverted, same size as the object. Case 4, if the object is in between center and focus, then image will be beyond the center, the nature of image is real, inverted, enlarged image, okay, the size of image is greater than the object. Case 5, when the object is at the focus, okay, that means the object distance is equals to focal length, then the image will be at the infinity, real, inverted, enlarged image it will be, okay. Case 6, last but not least it is, okay, it's very you have to remember this. Case 6, when the object is in between focus and pole, then the image formed will be what shall erect enlarged image, A virtual erect enlarged image is possible only by the concave mirror. Virtual erect enlarged image is not possible by the convex mirror. Okay, I hope you got it. Virtual erect enlarged image is possible only by the concave mirror, not by the convex mirror. Okay, but then what is possible by the convex mirror? Virtual erect diminished image is possible by the convex mirror. You have to keep it in mind. Are you clear with that? I hope. So there are 6 possibilities, just like I remember and I have just read in front of you, right? You have to remember them and you should recall during the exam, then only it will be helpful for you. Okay, and you should not forget the 6 cases. And convex mirror, okay, it's not lens, I'm sorry. Convex mirror has 2 cases only, just 2 cases. Okay, those 2 cases we discussed already, but I can tell you those 2 cases here. Case 1, when the object is at infinity, the image will be at the focus. Nature of image is virtual erect diminished. Virtual erect diminished. Case 2, when the object is not at infinity, somewhere less than infinity, then the image will be in between focus and center. Not focus and center, the image will be in between focus and pole of the mirror. Okay, and the nature of image is virtual erect diminished image. I hope you got the clarity. And for common condition, I have to tell you here, for concave mirror or convex mirror, if the object is at the pole, okay, and very close to the pole, then a curved mirror behaves as a plane mirror. Curved mirror behaves as a what? Plane mirror. I hope you got the clarity here. And you must remember the 6 possibilities in the concave mirror and 2 possibilities in case of convex mirror, and regarding this everything given in the class. Okay, it is there in your notebook, just read them. Important topics these are. Okay, next these are the regarding mirrors. Okay, just it is image formation. I did not explain what is sign convention also. Now I'm not explaining here because I have already explained in the class. Just read the sign convention. Try to get the clarity on sign convention, because without sign convention you can't solve the problems in the ray optics. If you understand wrongly the sign convention, or if you have some understanding problem in the sign convention topic, definitely you'll get the wrong answer. So be careful in case of sign convention, you must be very clear. Okay, and for sake of clarity, I read the sign convention here, just listen. Okay, sign convention is very simple. First thing is, the ray which is going in the direction of, the distance in the direction of incident ray is positive, in the opposite direction of incident ray is negative. Above the principal axis the height is positive, below the principal axis it is negative. All the distances are measured from the pole. Okay, this is very simple and straightforward sign convention. It is easy to remember, but when you are trying to apply, you have to use your brain. Okay, so just try to get the clarity on sign convention. If you have doubt, come to me and ask that. Okay, thank you. Next, this is about the mirrors, and what is the common formula for mirrors? It's very simple. I given already. The mirror formula is common for both the mirrors. But the thing is, if I classify this formula for both, there will be some minor changes. And for real object, I am writing real object. Remember, for real object, U is always negative. In entire ray optics, whichever the phenomena you are studying, for the real object, according to Cartesian sign convention, the object distance is always negative. So 1 by V minus 1 by U. Okay, and if I write for concave mirror, which is equals to minus 1 by F, because for the concave mirror focal length is negative. Remember, for the concave mirror focal length is negative. Okay, and for convex mirror you can guess focal length is positive, plus 1 by F. Okay, just whether plus 1 by F or minus, that matters whether convex or concave. If you are dealing with a concave mirror, then you have to take minus 1 by F. Dealing with a convex mirror, you have to take plus 1 by F. Okay. Based on this, of course, there will be magnification formula. The magnification is minus V by U. with sign convention you have to use this formula. When you are using this formula, you must not forget that you have to apply the sign convention. Remember, after applying the sign convention, suppose you got the magnification positive, it indicates it is a virtual image. Okay. Otherwise, you got negative, then it is indicating that it is a real image. Okay. Remember, positive magnification stands for virtual image, negative magnification stands for real image. Even in case of lenses also same symbol, same statements we have to remember. Okay, and based on this there will be a problem they will give you. Suppose the object and image size, they will give you comparison. They will mention the image is 3 times the object. Okay, the image is 3 times the object. And also they will mention the focal length, say 30 centimeters or 36 centimeters, and they will ask you to find out the possible object locations. Okay, by seeing this word image is 3 times the object, you have to consider that m is plus or minus 3. Why I am taking plus or minus 3? Because they have said clearly it is 3 times, but they didn't mention whether real or virtual. Okay, if it is real image, then the minus we have to consider. If it is virtual image, then plus we have to consider. So by taking plus 3 you have to solve the problem, and taking minus 3 you have to solve the problem. Okay, and you will get the 2 different object distances, u1 and u2. And how to solve the problem? You have to take that v equals to 3 times u, and you should use these 2 equations. For concave mirror you have to use minus 3 here, for convex mirror you have to use plus 3 here, and substituting here you will get the answer for them. And we have discussed this model in the board. Okay, I am saying that this model is important. If you can remember my class, you can easily solve this problem. Okay, this is regarding the mirror, both mirrors, concave and convex mirrors. And one more thing, the question they can ask you, by immersing in any other medium, whether the focal length of the mirror will be changed? No. Okay, because in case of mirror, the phenomena involved is a reflection. Okay, by immersing a mirror into another medium, you are changing the refractive index, but reflection is independent of the refractive index. Okay, refractive index is considered only when there is a ray which is going from one medium to other medium. Okay, but in case of reflection, there is no passage of ray from one medium to other medium. So only if you consider the experiment, reflection experiment in air and the same reflection experiment in the water or any other liquid, you have to get the same values. Okay, it is independent of the medium. I hope you got it. And next topic that we can enter is the refraction. Of course, as I told you, refraction at plane interface. Of course, here refraction. Before going to see the refraction at plane interface, I should tell you the laws of refraction. They are important again. First law, that is what Snell law. It is the product of refractive index and sine of the angle must be always constant. That is mu into sine I is constant. Or we can say sine I by sine r equals to mu 2 by mu 1. Here you may get a doubt that what is mu. The mu is refractive index. There are 2 types of refractive indices, absolute refractive index, relative refractive index. Absolute is C by V, relative is V1 by V2. Okay, if you compare the 2 different media, then it is relative refractive index. If you compare any medium with a space, with a free space, that is absolute refractive index. Remember, relative refractive index can be greater or less than 1 or sometimes equals to 1. Okay, but absolute refractive index is always greater than 1. Absolute refractive index is always greater than 1. It will never be less than 1. It is because of the fact the light speed cannot be greater than the speed of light in the free space in any other medium. If you take the different media, okay, then in any medium the speed of light cannot exceed the value 3 into 10 to the power of 8 meters per second. That is the upper speed of the light. Okay, maximum speed of the light is 3 into 10 to the power of 8. That is the reason the refractive index, absolute refractive index must be always greater than 1. Okay, and here itself there will be one concept, that is apparent length and actual length. Okay, optical path and geometrical path. Remember, optical path is always greater than or equals to geometrical path. Okay, optical path equals to refractive index into geometrical path. Okay, it is because of the lowering of the speed of light in the medium, we will consider the length of the length is increased. Okay, that we have to consider, so right, that is optical path is greater than or equals to actual path. When it is equals to actual path, when the refractive index is equals to 1, then optical path and actual path are equal. If it is greater than 1, then it will be, optical path will be greater than actual path. So I can tell you optical path is equals to actual path into, refractive index into actual path. Actual path is say L, then mu into L. Okay, path difference also we can find. The path difference we will discuss in wave optics, this one. The path difference equals to optical path minus actual path. So mu minus 1 into L. This is the path difference, right? And regarding this, in case of wave optics, we will discuss. And coming to the refraction at plane interface, as I told you already, there will be 4 cases. Remember these 4 cases I given already in case of our classroom, like case 1, case 2, case 3 and case 4. Okay, there are mainly 2 different cases. One is a real object is in rarer medium, real object is in denser medium, and next virtual object in rarer medium, and virtual object is in the denser medium. Okay, these 4 cases if you can remember, you can answer anything there. Okay, I can tell you the whatever I taught there, I can tell you here, and of course I told you to consider the common symbol here. The refractive index mu equals to mu denser by mu rarer, like this one notation I given. Okay, like this one notation. And if the real object is in rarer medium, then apparent is greater than actual. Okay, if the real object is in denser medium, then apparent is less than actual. If the virtual object is in rarer medium, okay, virtual object is in rarer medium, what happens here? This we have discussed already. If the virtual object is in rarer medium, I have to draw that, just forgot it. So this is rarer, this is denser. The virtual object is in denser medium, rarer medium, a converging beam should be going here. Denser to rarer, it should go away from normal. So this way, yeah. So I can tell you object V is greater than U. Right? Virtual object is in rarer medium. A virtual object is in denser medium. So case 3, case 4. Virtual object in the denser medium. The reverse of this will come. Okay, the V is less than U. Okay, and these 4 cases I have clearly explained in the class. You have to remember them. Okay, you have to read them, right? And I told you already, always the shift X is always the difference in apparent and actual. Apparent is image distance, actual is object distance. The gap between image distance and object distance is called shift. Okay, I hope you got it. And here itself we have to discuss the total internal reflection and also critical angle. Remember, for critical angle sin C equals to 1 by mu. What is mu here? I given already. This mu equals to denser mu by rarer mu. Okay, so sin C is 1 by mu, then C equals to sin inverse of 1 by mu. Okay, what is C? This is the critical angle. Regarding critical angle you have to read, and this is important. Okay, and coming to the total internal reflection, this is important again. Total internal reflection definition you have to remember. If the angle of incidence is greater than the critical angle, then the ray is not refracted, it will be reflected into the denser medium again. The requirement here must be the ray should go from denser to rarer, and angle of incidence must be greater than critical angle. These two conditions it must be satisfied. Okay, if it is not going from denser to rarer, then if it is coming from rarer to denser, then total internal reflection is not possible. Okay, so two conditions you have to remember. And one more thing, whether critical angle depends on temperature? Yes, of course. Okay, that you have to read. As the temperature increases, critical angle decreases. Okay, and one more thing here, the deviation in case of total internal reflection, the variation of the deviation you have to discuss. So it's very simple. That is this way it will be. This diagram also I given. This is angle of incidence and this is the deviation. Okay, and of course this is pi by 2 minus c. This is pi minus 2c. Okay, this graph clearly I have explained. From this graph also you may get the questions. Okay, and in the total internal reflection you have to discuss optical fiber cable. Okay, you have to remember this optical fiber communication. In that optical fiber cable we have discussed there will be core and cladding. Okay, and the core refractive index is generally greater than the cladding refractive index. The light is going from core to cladding so that it will get reflected back into the core again. Okay, this is about the refraction at plane interface. Now coming to the next step, the refraction. Okay, refraction there will be two cases I told you already, that is plane interface. Wait, I have to give you one important formula, that is for any refraction, a general formula you have to remember. Refraction at any interface, it is mu2 by v minus mu1 by u equals to mu2 minus mu1 by r, right? And here I should explain what is mu2, what is mu1, what is u and v are. Okay, remember mu1 is the refractive index of the medium in which the object is existing. Okay, mu2 is the refractive index of other medium. Alright, v is the image distance, u is the object distance, r is the radius of curvature of the interface. Remember, also you can remember this, convex interface radius of curvature generally positive. Okay, and concave interface generally negative. This you can't say directly, you have to see the problem. First of all, if you take this one for example, what kind of interface, if I ask you now at this stage you can't answer, because if I say mu1 here and mu2 here, suppose I have to mention which one is greater. Suppose mu2 is greater than mu1, then it is convex interface. Otherwise, if mu2 less than mu1, it is going to be concave interface. Depends on the refractive indices actually. Okay, so you have to be careful. But the thing is, if you place over here object, the object distance is u, right? And for this case, this formula you can use. And you can ask me a doubt, how we can use this formula for plane interfaces? Remember, for plane interface, radius of curvature is infinity. I told you already. So this something by infinity will become 0. The right hand side of the entire equation will become 0. So mu2 by v minus mu1 by u equals to 0, or v equals to mu2 by mu1 times the u. This is a common formula in case of any, in case of refraction at plane interface. We have discussed in the previous board, this board. Okay, here, okay, this formula v equals to mu2 by mu1 into u. This formula is applicable for all these four cases, right? And you should remember that. And that formula is coming from this common formula, right? And this formula derivation is not required. Okay, it is not suitable. It is not required to NEET or JEE preparation. Derivation is not required, but the formula is important. Based on this, you can solve the problems. Okay, you have to remember this. So as I told you already, this is convex interface. If it is concave interface, then you have to take like this. This is concave, and the refractive index mu2 greater than mu1. This is mu1, right? Yeah, this is a concave interface. What is different for the concave interface? The radius of curvature may be negative. Depends on again the object location. If it is lying in mu1, you have to take that is also sign convention. You have to remember the sign convention. Okay, sign convention. If you forget now, you can't answer the positive or negative for this R. Okay, so sign convention is very important. I told you already sign convention just now, just for 10 minutes back. I told you that we have to remember that, right? And of course, if the paper is more difficult, they can ask you. In this cases also, like for convex interface, there will be 4 different cases. For concave interface, there will be 2 different cases. Then total refraction through curved interface will have 6 cases. Okay, those 6 cases is not necessary. Okay, they are not required for the NEET exam. So just you can just see them, try to remember, that's it. But we can't expect any question from them unless the paper is difficult. They will not give that model in the exam. Okay, this is refraction through the plane interface, which is important again. Next, lens. Okay, once coming to the lens, remember lens maker's formula is important. Lens maker's formula is 1 by f equals to mu for lens or mu for glass by mu for medium minus 1 into 1 by R1 minus 1 by R2. Okay, this lens maker's formula is important, right? And thin lens formula, here itself thin lens formula will be there, 1 by V minus 1 by U equals to 1 by F. I told you already there will be two types of lenses. Convex lens, concave lens. Convex lens will have 6 cases image formation. Concave lens will have 2 cases image formation. Total 8 cases we will have to discuss that. Okay, let us enter into the lens topic. Lenses. Convex lens, they are also called as convergent lens. Concave lens, they are also called as divergent lens. Okay, convex lens, there will be 4 cases again. Those 4 cases you have to remember, and they are called biconvex lens, equiconvex lens, plano-convex lens, concavo-convex lens. Okay, I repeat, biconvex, equiconvex, plano-convex, concavo-convex, right? And for concave lens, there will be 4. They are biconcave, equiconcave, plano-concave, convexo-concave. These 4 you have to remember. Okay, but we can simply you can remember that for all convex lenses, focal length is positive. Okay, for all concave lenses, focal length is negative. Right? For all 4, this is positive and this will be negative. I hope you got the clarity. Right, but for each convex lens, mainly we will consider equiconvex lens. Equiconvex lens meaning the radius of curvature for both sides is equal, R and R. Okay, radius of curvature is same, then it is called equiconvex lens. For this case, we have to consider 6 cases, 6 possibilities. Case 1, case 2 and so on, case 6. Okay, and I am going to read out those 6 cases and you have to remember. If you forget them, you have to read the notebook and try to remember these 6 cases. Okay, so case 1, if the object is at infinity, image will be at focus on the other side of the lens. Okay, the nature of image is real, inverted, diminished image. Real image, inverted image it is, and diminished, very point size image it will be. Okay, that is case 1. Case 2, if object is beyond the center means what? Object distance is greater than 2f. Then image will be in between focus and center, that is f and 2f. Nature of image, it is real inverted diminished image, right? Case 3, if object is at the center, that is u equals to 2f, then image will also be at the 2f but on the other side of the lens. The nature of image will be real inverted same size of the object, right? Case 4, if object is in between focus and 2f, that is f and 2f, then image will be beyond the center, okay, it will cross the center and go outside. Nature of image, it is real inverted enlarged image, right? Case 5, if the object is at focus, then image will be at infinity, real inverted enlarged image. Case 6, it is also called as simple microscope condition. Case 6, if object is in between focus and optical center, okay, optical center you know already, optical center is this, okay. So if the object is in between focus and optical center, then image form will be virtual erect enlarged image. Remember, a convex lens can form virtual erect enlarged image. A concave lens cannot form the virtual erect enlarged image. It always forms the virtual erect diminished image. You have to maintain the clarity. Okay, is that clear? Yeah. So case 6 of the convex lens is the simple microscope or magnifying lens. In your stationery shop you can get it. Okay. So in this, what is the nature of image? It is convex lens in case of if the object is situated in between the optical center and focus, then it will form virtual erect enlarged image. Behind the object it will be, okay, object is there and image will be behind the object. Okay, these are the 6 cases and 2 cases for the concave lens, only 2 cases. Case 1, if object is at infinity, image will be at the focus, virtual erect diminished image will be, okay. Case 2, if object is not at infinity but somehow close distance to the lens, then image form will be virtual erect diminished image, okay, but not at the focus. Are you clear with that? So I told you already, here 6 cases, here 2 cases. You have to remember total 8 cases. Just like the convex mirror and concave mirror, here convex lens and concave lens you have to remember, right? This is about the lenses. And one more important topic regarding the lens is the displacement method. How to find the focal length of unknown lens. Convex lens is there, that is displacement method, okay. Then displacement method you have to use and find that experiment is important. And next, cutting a lens is important, right? Silvering lens is not in the syllabus, right? Immersing a lens in a medium is it may be important here, right? You can read that also. It's very small topic we have discussed in the class, right? Cutting and silvering. And next, 2 or more lenses are in contact. Thin lenses in contact also you can. Thin lenses in contact also you can read them. After this, what we can say, power of optical instruments. Power, okay. Power of lens, power of mirror. For both cases you have to learn regarding the power. For power, for lens it is 1 by focal length, okay, and for mirror it is minus 1 by focal length, okay. This is very simple. The power also you have to remember. I hope you got the clarity here. And this is about the ray optics lenses. And coming to the dispersion and prism, we cannot say something is important in like something is unimportant here. Okay? In case of prism, everything is considerable. You should not neglect any single topic from the prism. You have to read completely the prism conditions. And also rainbow formation and scattering, these are very small topics. This also you have to remember, because conceptually they are important. If they are making conceptual questions, definitely they will ask from the rainbow formation or scattering also. Raman scattering, Rayleigh scattering, these two things we have to discuss, right? And going to the optical instruments, here also we can't say one instrument is more important, another is less, okay? Like we can't say that. All the 4 instruments, there are only 4 instruments. One is simple microscope, compound microscope, these 2 are called microscopes, and the remaining 2 are telescopes: astronomical telescope, Galilean telescope, terrestrial telescope, okay? 3 telescopes. These 2 plus 3, total 5 optical instruments are important. We can't sort out something is important, something is unimportant here, okay? We have to learn everything in case of optical instruments, okay? Thank you.